commercial buildings, the rarity of 15-amp circuits stems from several key factors. Firstly, increased electrical demand is a primary consideration. Commercial spaces inherently host a greater density of electrical devices compared to residential settings. Think about the proliferation of computers, printers, copiers, and other office equipment, all drawing power simultaneously. A 15-amp circuit simply lacks the capacity to reliably support such a concentrated load, potentially leading to frequent overloads and trip breakers, which can disrupt business operations. Secondly, building codes often play a significant role in this practice. Many jurisdictions have regulations that stipulate a minimum circuit rating of 20 amps for commercial applications. This requirement is intended to ensure adequate electrical capacity and safety, minimizing the risk of electrical fires and related hazards. The specific code requirements can vary depending on the location and the type of commercial building, but the underlying principle remains consistent: prioritize sufficient electrical capacity. Thirdly, accepted design practices within the engineering and architectural fields contribute to the prevalence of 20-amp circuits. When designing electrical systems for commercial buildings, engineers and architects typically adopt 20 amps as a standard default. This is not merely an arbitrary decision, but a pragmatic one driven by the greater versatility and flexibility offered by 20-amp circuits. A 20-amp circuit can accommodate a wider range of electrical loads compared to a 15-amp circuit, providing greater headroom for future expansion or changes in equipment usage. This forward-thinking approach minimizes the need for costly and disruptive electrical upgrades down the line. Now let's consider some specific scenarios. While the general rule favors 20-amp circuits, there might be occasional exceptions. For instance, a small, dedicated exhaust fan with a low power consumption might be deemed suitable for a 15-amp circuit. However, such instances are relatively rare and typically involve careful evaluation of the electrical load to ensure it remains well within the circuit's capacity. Generally, it's best to avoid using 15-amp circuits in commercial buildings due to the high electrical demand, building code requirements, and the more versatile design capabilities of 20-amp circuits. To delve deeper into the technical aspects, it's helpful to understand the relationship between amperage, voltage, and wattage. Amperage, measured in amps, represents the amount of electrical current flowing through a circuit. Voltage, measured in volts, represents the electrical potential difference that drives the current. Wattage, measured in watts, represents the amount of electrical power consumed by a device. These three quantities are related by the formula watts equals volts times amps. In a standard 120 volts circuit, a 15-amp circuit can deliver a maximum of 1800 watts of power, while a 20-amp circuit can deliver a maximum of 2400 watts. This additional capacity of a 20-amp circuit provides a significant safety margin and allows for the connection of more power-hungry devices. Furthermore, the National Electrical Code (NEC) provides comprehensive guidelines for electrical installations, including circuit sizing and overcurrent protection. The NEC specifies the types of conductors, or wires, that are permitted for use in different circuit sizes and applications. For example, a 15-amp circuit typically requires a minimum wire gauge of 14 American wire gauge (AUG), while a 20-amp circuit typically requires a minimum wire gauge of 12 AWG. The larger wire gauge of a 20-amp circuit provides a lower resistance path for the electrical current, reducing the risk of overheating and voltage drop. Overcurrent protection, such as circuit breakers or fuses, is essential for protecting electrical circuits from overloads and short circuits. These devices are designed to automatically interrupt the flow of current when it exceeds a predetermined threshold. The NEC specifies the maximum overcurrent protection rating for different circuit sizes. A 15-amp circuit must be protected by a 15-amp circuit breaker or fuse, while a 20-amp circuit must be protected by a 20-amp circuit breaker or fuse. It's crucial to select the correct overcurrent protection rating to ensure that the circuit is adequately protected without causing nuisance tripping. In addition to circuit sizing and overcurrent protection, the NEC also addresses receptacle spacing requirements in commercial buildings. These requirements are intended to ensure that electrical outlets are conveniently located and readily accessible to occupants. The NEC typically requires that receptacles be spaced no more than 12 feet apart along walls and that at least one receptacle be provided for every 12 feet of wall space. The specific receptacle spacing requirements can vary depending on the type of commercial building and the intended use of the space. The increased use of electronic devices in modern commercial buildings has also led to the growing popularity of arc fault circuit interrupters, or FSIs, and ground fault circuit interrupters, or GFCIs. FSIs are designed to detect and interrupt arc faults, which are dangerous electrical conditions that can cause fires. GFCIs are designed to detect and interrupt ground faults, which are electrical conditions that can cause electric shock. The NEC requires the use of FSIs in certain locations, such as bedrooms and living areas, and GFCIs in wet locations, such as bathrooms and kitchens. To further enhance the safety and reliability of electrical systems in commercial buildings, regular inspections and maintenance are essential. Qualified electricians should conduct periodic inspections to identify any potential problems, such as loose connections, damaged wiring, or overloaded circuits. Maintenance tasks, such as tightening connections and replacing worn-out components, can help to prevent electrical failures and extend the lifespan of the electrical system. Finally, it's important to remember that electrical work should always be performed by qualified and licensed electricians who are familiar with the NEC and local building codes. Attempting to perform electrical work without the proper training and experience can be dangerous and can lead to serious injury or property damage. In summary, the preference for 20 amp circuits over 15 amp circuits in commercial buildings is a multifaceted issue driven by electrical demand, building codes, design practices, and safety considerations. Understanding the underlying principles and the relevant NEC requirements is essential for ensuring the safe and reliable operation of electrical systems in commercial environments. Let's consider a hypothetical scenario to further illustrate the points discussed. Imagine a small office space within a larger commercial building. This office space contains several computers, printers, task lights, and other common office equipment. If the office space were wired with 15 amp circuits, it would likely experience frequent overloads and trip breakers, especially when multiple devices are operating simultaneously. The employees would be constantly interrupted by power outages, and the productivity would suffer. In contrast, if the office space were wired with 20 amp circuits, the electrical system would be able to handle the combined load of all the devices without any problems. The employees would be able to work without interruption, and the office would function smoothly and efficiently. Furthermore, the 20 amp circuits would provide a greater safety margin, reducing the risk of electrical fires and other hazards. The building owner would also have greater flexibility to add new equipment or make changes to the office layout without having to worry about the electrical capacity. In addition to the practical benefits, using 20 amp circuits in commercial buildings also demonstrates a commitment to quality and professionalism. It shows that the building owner or manager is willing to invest in a robust and reliable electrical system that can meet the needs of its tenants. This could be a valuable selling point for attracting and retaining tenants, especially in competitive markets. Of course, there are some costs associated with using 20 amp circuits instead of 15 amp circuits. The materials, such as wires and circuit breakers, are slightly more expensive, and the installation labor may also be slightly higher. However, these costs are relatively small compared to the long-term benefits of having a more reliable and versatile electrical system. In conclusion, the decision to use 20 amp circuits in commercial buildings is a sound investment that pays off in terms of increased reliability, safety, and flexibility. It is a best practice that is widely adopted by engineers, architects, and building owners who prioritize quality and performance. The additional capacity of 20 amp circuits provides a significant advantage in handling the higher electrical demands of commercial environments. The code requirements help ensure safety and compliance. It would also be useful to delve into the specifics of conductor selection for both 15 amp and 20 amp circuits. As mentioned earlier, the NEC typically requires a minimum wire gauge of 14 AWG for 15 amp circuits and 12 AWG for 20 amp circuits. However, there are several factors that can influence the appropriate conductor size, including the length of the circuit, the ambient temperature, and the type of insulation used. For example, if a circuit is particularly long, the voltage drop along the conductor can become significant, which can reduce the performance of the connected devices. In such cases, it may be necessary to use a larger conductor size to minimize the voltage drop. Similarly, if a circuit is installed in a high-temperature environment, the ampacity or current carrying capacity of the conductor may be reduced. In this case, it may be necessary to use a higher temperature rated conductor or a larger conductor size to compensate for the reduced ampacity. The type of insulation used on the conductor also affects its ampacity. Conductors with high temperature rated insulation can carry more current than conductors with lower temperature rated insulation. The NEC provides detailed tables that specify the ampacity of different types of conductors under various conditions. These tables should be consulted when selecting the appropriate conductor size for a particular application. Another important consideration is the type of wiring method used. The NEC recognizes several different wiring methods, including conduit, cable, and open wiring. Each wiring method has its own set of requirements and limitations. For example, conduit provides excellent protection for conductors against physical damage and moisture, but it can be more difficult to install than cable. Cable is easier to install than conduit, but it may not provide as much protection against physical damage. Open wiring is the least expensive wiring method, but it is only permitted in certain applications. The choice of wiring method depends on the specific requirements of the installation and the preferences of the electrician. In addition to conductor selection, the selection of overcurrent protection devices is also critical for ensuring the safety of electrical systems. Circuit breakers and fuses are designed to protect circuits from overloads and short circuits. When an overcurrent occurs, the circuit breaker or fuse will trip, interrupting the flow of current and preventing damage to the wiring and connected equipment. It is essential to select the correct overcurrent protection rating for a particular circuit. The overcurrent protection rating should be no larger than the ampacity of the smallest conductor in the circuit. If the overcurrent protection rating is too large, the circuit may be overloaded without tripping the breaker or blowing the fuse, which can lead to overheating and potentially a fire. The NEC provides detailed guidelines for selecting the appropriate overcurrent protection rating for different types of circuits. These guidelines should be carefully followed to ensure the safety of the electrical system. Finally, it is important to emphasize the importance of proper installation practices. Even if the correct materials are selected, a poorly installed electrical system can still be dangerous. All electrical work should be performed by qualified and licensed electricians who are familiar with the NEC and local building codes. Proper installation practices include ensuring that all connections are tight and secure, that conductors are properly supported and protected, and that all equipment is properly grounded. Grounding is an essential safety feature that provides a low resistance path for fault current to flow back to the source. This helps to prevent electric shock and minimize the risk of electrical fires. The NEC provides detailed requirements for grounding electrical systems. These requirements should be carefully followed to ensure the safety of the installation. In summary, the design and installation of electrical systems in commercial buildings is a complex process that requires careful attention to detail. The preference for 20 amp circuits over 15 amp circuits is driven by a combination of factors, including increased electrical demand, building code requirements, and design practices. Understanding the underlying principles and the relevant NEC requirements is essential for ensuring the safe and reliable operation of electrical systems in commercial environments.